You're watching Saurabh and Sagar Show. Let's hear some facts about OLTP databases. OLTP systems are optimized for high volume of concurrent users performing fast read-write operations like those of e-commerce or banking.
OLTP databases are built for quick response times, even under heavy loads, ensuring real-time updates and transaction completion.
Without ACID properties, OLTP systems risk transactional inconsistencies leading to data corruption.
Normalization minimizes data duplication, which is essential when managing transactional integrity in real-time systems.
Indexing in OLTP is a double-edged sword. While indexing speed up read operations, they can slow down inserts and updates in high-write environments like OLTP databases. Please join us in conversation on the street with our special guest.
Guest is Kovid Rathee. He has been in the industry for over 13 years and he has done so many different roles. Started as a professor, has moved to software engineering, data analyst, and now is a principal solutions architect at Versen. Welcome, Kovid, to the Saurabh and Sagar Show.
Thank you. Thanks, Saurabh.
Welcome to the show, Kovid.
Thanks, Saurabh. Good to meet you.
Kovid, let's start with your current role. And what do you do as a principal architect?
Sure. My role, current role, is a principal solutions architect. I work for a tech consulting company called Versen, which recently got acquired by Telstra. My role involves a lot of pre-sales activities, working with clients, where I'm usually the first person to go in and understand what their needs are in terms of data architecture, what they're trying to do, what business problems they're trying to solve, and support them in whatever way we can in terms of like solution architecture and implementation of that architecture. It also involves a lot of partner management, practice development, learning and development for the whole team. So it's a broad brush sort of role where I'm involved in a lot of things, both technical and managerial.
Today's episode is all about OLTP. OLTP, from what I know, is online transactional processing system. What is OLTP? Why do we need OLTP?
I mean, these were OLTP databases were the first ones to be invented, essentially. And that's where we needed to process information. Analytical databases came in much later. And what we understand by OLTP databases, traditionally, these are more associated with relational databases, where we represent data in a tabular form. That comes with a number of guarantees, which is popularized as ACID guarantees, which essentially make up what a transaction is. So essentially, if you want to process some information, it has a guarantee that it will be processed in whole, in completeness, and it will be stored at a durable medium, which is the disk. And that's the guarantee. That's what makes a transaction. And those were the requirements for early applications. So that's how it came into being.
So what is ACID?
Yeah. So there are the four core principles of transactions. So atomicity, isolation, consistency, and durability. So atomicity essentially means a transaction might have multiple steps. So atomicity essentially means where the transaction will only be complete if all the steps are completed. If either of the steps fail, the whole transaction fails. So it's atomic in nature. Consistency means when an application is trying to write a transaction and two other systems are trying to read that the data. Both these systems get a consistent view of the data. Isolation is very similar to consistency because now applications have multiple transactions. When multiple transactions are going on for the same data, isolation makes sure that one transaction can't peek into another and the other one can't peek into the rest, making sure the data is essentially consistent. And then the last one, durability. All of these things eventually result into the storage of data into a durable disk medium. That's the guarantee. Those are the four guarantees that that ACID provides and that make up a transaction.
Great, Kovid. I think when we talk, it is mostly associated with relational databases, which has been there for a while. As you mentioned earlier, we started with relational database and OLAP systems came much later. But how do you associate an OLTP workload when in your business you're defining an OLTP workload, and now you have the new database called NoSQL databases. So you have an OLTP workload running on a relational database versus OLTP on NoSQL database.
Absolutely. It's not mandatory that a transactional system is a relational database. Just to clarify, a transactional system could be a NoSQL database, but it might have some limitations on the ACID properties that we just talked about. So a NoSQL databases, essentially, they came into being to address certain specific requirements of applications, which was related to full text searching, real-time time series databases, schema, freedom of schema, whereas the traditional transactional databases had a lot of limitations on how frequently you can change the schema and the costs associated with that. So once you commit to a schema, it's very expensive to change columns, add new columns, remove columns, and that's where the birth of NoSQL came into being. Databases like MongoDB, Cassandra, etc.
Does it mean it's schema on read?
No, so you don't have to. I mean that does mean schema on read, but it for some databases it's also schema on write. Like you can write any schema in a let's say document oriented database. You don't have to commit to a schema.
My interpretation of schema on read is when you write anything into a database, you don't have to worry about the schema nor the structure or data. And you can then put a schema or structure when you're reading it. So you can have a storage, but you can have multiple schemas and structure while reading the same data. To complete that, then does that mean the relational databases are schema on writes? Because you have to have a structure and everything in place while you're writing.
Absolutely. And that structure, it has pluses and minuses. So it has pluses. The benefits are it gives you a really, really fast performance because the database engine knows exactly what to expect. So it can be designed in a certain way. It can have predefined indexes. You can arrange the data in disk in a certain way to access it most optimally. Whereas in the schema on read situation, you don't have that freedom, and you have to do perform additional work to get there. So yeah, it's a balance between cost and the freedom that you want.
And one concept in OLTP is very relevant is concept of normalizations. You do a lot of normalization and performance optimizations. Could you tell us some light on how you optimize a normalized OLTP database?
Yeah, sure. I mean, normalization is just a modeling technique that aligns with how your application interprets different entities in the real world. So it's almost like an object-oriented sort of modeling modeling approach. So you break down your application entities into different things based on how your application writes data into the database, and then you can scale them individually. You can model them individually. Oh, sorry, what was the other question?
Optimization, so performance optimization. So because many times normalizing databases into like suppose 3NF form introduce a lot of join queries, and it might interfere with your performance of your query. So how do you create a balance between optimizing your structure for performance versus
Correct
normalization? So
before he answers, I just want to make sure I put this in a very simple layman's term. My definition of normalize is there is no duplication. You have got data in one structure in one table. When you want a particular fact or attribute, you'll only get it from one place. You will never have it in multiple places. While denormalize is storing it in multiple places, so you have duplication, but then it's very easy to access the data for the information and for the requirements that you have.
That's correct. Just one point to add there. It's not that the normalization, with normalizations, there's no duplicates. There's several degrees of normalization, degrees of normal forms and goes up till 6 novel form or something. There are different degrees, and the level of duplication depends on what level of normalization you use. Yeah, that's correct, essentially.
In the old days, you used to have relational database deployed on-prem, and we went through the days of Oracle and SQL Server and licensing and optimization. Now we have cloud platforms like AWS, Azure, Google Cloud, Snowflake. So how do you see this, the adoption of cloud platform and introduction of these relational database, like more in the form of managed database or serverless database, has impacted the way we scale and build systems on OLTP databases?
Absolutely, it has in a very big way. The first 3 startups that I worked for, most of my job was always like managing MySQL databases, managing replication, and managing the performance of those databases, and these were running on EC2 instances, not even RDS. All the technical and administrative work related to databases has now been offloaded to cloud platforms. Essentially, they're managing that for us. It comes at a cost, but they're managing that. Replication is one. There's disaster recovery. There's failovers. There's observability. And in some cases, some cloud platforms services also offer some sort of recommendations around performance, where they'll go ahead and suggest you what indexes to create, whether a table should have partitions or not, that sort of stuff. So it does take a lot of load off the companies, especially the smaller ones who can't afford to hire specialized database administrators to run MySQL or Postgres instances. So it removes that barrier for entry.
That's great. The discussion on OLTP database is incomplete if I don't talk about microservices.
Oh, right.
So tell us, how does the Microsoft architecture works in conjunction with OLTP databases, and what has changed from building monolith application with OLTP to now world of cloud microservices with OLTP?
Well, again, see, with the microservices architecture, it gives you an option to have smaller databases aligned to different services. Again, this comes with a lot of benefits. That the first benefit is you're operating individually, so you can scale the services differently. You can scale those databases differently. But then the challenge there is how to integrate all that data when you want to consume it downstream, especially when it comes to analytical applications. So the scaling problem is solved, but then the integration problem arrives, and then you have to integrate all that data. And one of the things that I've done in the past is like have a multi-source of like fan-in replication, having multiple databases replicated into one, which can be challenging.
Let's talk about NoSQL. And when I say NoSQL, I think it's called not only SQL. Why do we need NoSQL? Is there a really requirement for NoSQL databases, or we can still be good with relational databases?
Well, relational databases are actually really powerful. So I have some sort of bias towards them. They're really powerful, but at scale, and when you're trying to solve very specific problems, the cost implications can be really high with relational databases, because they're not meant to address certain workloads. They're not designed to do that. For instance, both MySQL and Postgres or Oracle provide full text search capability. You can create a full text search index, but it's not optimized. When you think about full text search, you always think about something like Elasticsearch or Solr or something like that. And those are what Amazon has popularized as purpose-built databases. So they're designed to solve a particular type of problem. And I think there is space for that. Similar with a number of time series databases. They are engineered in that way. The way they handle transactions at a file level, system level, how they maintain transactions, how they maintain data, how they maintain commits. Everything is implemented to solve that certain problem, to deal with a certain type of volume, a certain type of schema, and that's where there is space for these databases. Similar with graph databases. You can implement a graph database within a relational database, where it would require a lot of work.
Let's talk about migrations when it comes to OLTP. Tell us about your experience on moving those systems and what is required.
Sure. My experience has mostly been moving from self-managed, self-hosted MySQL and Postgres instances to the cloud. So it's not necessarily on-prem. It's still in the cloud, but we've moved from self-managed, self-hosted to managed services in the cloud.
And it's still SQL to SQL. So SQL Server to SQL Server or SQL Server?
So we have done both homogeneous and heterogeneous. So MySQL to Postgres, Oracle to Postgres, Postgres to Oracle, all of that stuff. So it's always challenging the versions, the SQL standard, because not all databases are ANSI compliant. Standard they don't support the standard SQL syntax. Migrating data is the easy part. You just have to take care of that. You don't lose data because of precision, especially numbers. You don't lose data because of character encodings and things like that. The hard part is migrating existing workloads. How do you spend that time migrating existing queries, existing reports, dashboards, and things like that when you're migrating all the transactional workloads? And also, then how do you refactor your application to handle the change of database? That's the hard part. Migrating. There are plenty of tools that help you migrate from MySQL to Postgres. They'll just convert the schema. You just have to verify it whether it's correct or not.
So could you tell us what are the tools have you used doing any of the migrations?
Yeah. So most of because most of my experience is AWS based. So AWS has this amazing tool called Data Migration Service. I've used most of the times I've used that, and it comes with a sort of free tool called Schema Conversion Tool, which helps you convert one database schema into another. But it does need some oversight, essentially, to make sure that the Schema Conversion Tool is not incorrect. It is correct most of the times, but it might need some tweaks. And DMS is essentially a managed replication / CDC / migration tool. So it can be used for many things. And it's very simple to set up, and you can do lightweight transformations on the fly. Also, not recommended. I've tried that. But yeah, it's a really easy tool to use and helps you migrate from one database to another really quickly. Homogeneous migrations are super easy. Heterogeneous migrations require some work, especially with the schema conversion tool.
That's great. And do you see any common mistakes or best practices around the migration?
The most common mistakes are around data types and figuring out the conversion is fine or not. Encoding is especially a really hard problem to solve. I've encountered situations where we're migrating multiple databases, and every database, in fact, a lot of tables had different encoding. So essentially, making sure that those encodings translate into the target database, and no data is essentially lost, or special characters don't get introduced, or they don't create line breaks, and the data ingest fails in the target database. So those are sort of like technical challenges that you face during migration. There are also restrictions or limitations on what a DMS can handle in terms of migration. Everything is well documented, so you just need to make sure that your data doesn't have, for instance, long back there was some restriction around geospatial handling of geospatial databases or very large JSON fields. So you just need to be careful about how you handle that. There are ways to fix that. There are ways to work around that, and they're very well documented. Those are the mistakes people make.
Yeah. And Kovid, you mentioned the most complex part of migration is not data, but more workload migration, like migration of your SQL query, stored proc, or any reports. Do you have any approach, any best practice you have used in migrating workloads? Any tools in rewriting the queries if it is a heterogeneous migration? How do you rewrite the SQL queries or optimize query for the target platform?
I mean, there are similar tools. I can't. I remember a specific one, but tools that I've used. I've not used a cloud platform-based tool for this, but there are other tools that help you convert queries from one syntax to other. Obviously, this has completely changed now with generative AI, which can help you do that much easily.
I was about to ask question.
Yes.
What's your thought about using Gen AI as something as a powerful tool?
Can I interrupt you guys there? You guys have a wrong answer to that question. he asked which tools you're using, and you gave answer of which tools. I think the answer should be not tools, services, because you both are from consulting companies. You should be telling tools are not going to help you. It's services that was going to help you.
I mean, that's a technicality. And good catch, Sagar. Also,
It is hard. Like even for working as a consultant, I can say I've been part of some of the migration projects. I think building, or looking at a service which does it, it's hard, especially when it's heterogeneous migration. The migration of workload is the hardest part of any migration, where you said COVID.
I'm going to interrupt again, but this is very interesting. And I want to ask this question to both of you. How many successful migrations you have been? If you take a ratio of success versus failure, how many migrations were successful? Are there more migrations which are successful or more which are failures?
can I go first?
Yep.
Do you mean success at the first attempt?
No, success at whenever you can.
Most of the migrations we've done with past companies, there was no option to fail. Essentially, we were working for startups. If the decision was made to migrate to a database, we had to do that. It was a matter of what amount of testing went into it. So one example I can share with you was this was a particularly difficult migration where we were moving from one database to another, while also changing the schema completely. So this was the heterogeneous migration, but also heterogeneous in terms of schema. So the base was being remodeled and the database was getting shifted. So that was very, very challenging to how do we make sure that the records have been loaded properly, the relationships are still maintained, there are no integrity issues between tables, all the foreign keys are still valid. That was a very, very hard problem to solve, and a lot of testing went into that.
I have a nice word for that, Kovid. I mean, generally, like we call these kind of migration as modernization and not migration. You literally redesign the schema and write it and build it, the target system. Literally modernize the system. Yeah.
Sure. But this was just a database modernization then, because the application was yeah.
Well, I'd like to answer your question, Sagar. I've seen there are two categories of projects. One is if you work for enterprise client, very large scale migration where your source system is designed very poorly, the architect. So look, during the migration, your architecture of your current platform gets exposed, and then the success of the migration depends on how poor your current architecture and platform is, right?
And that,
as an architect, based on my experience, I would recommend better pick your use cases and modernize by use cases. Like, in transition, don't do a big bang migration. Better do a migration in a staggered way or modernize you based on use cases. Yeah,
I agree.
So we have so many different databases when you talk about OLTP. So, you've got IBM DB2. Informix is really a good system when it comes to OLTP. We have got systems, technologies coming from Oracle. We have got Microsoft, AWS is there. We've got NoSQL databases, MongoDBs, and, all those systems. So if you were going to design a OLTP system, which database you will pick?
Well, again, this comes from my experience and my bias with databases, the ones I've worked with. So the ones I've most spent time with is Oracle, MySQL, and Postgres. And my favorites are, I have a preference for open source stuff. So MySQL and Postgres. Postgres, I think, is extensible. It's designed for developers' freedom, and you can create a whole lot of different types of applications with that. MySQL is pretty much the same. It's really good. It's very scalable. I mean, companies like Uber, LinkedIn, Facebook, all of these have used these databases and scaled them to new heights. Although they've also developed their own database engines for MySQL. So Facebook developed something called RocksDB to support their MySQL workloads. Other companies have done the same. So, but yeah, these are the two that I'm most comfortable with.
How do you think the AI and the age of Gen AI will shape the future of OLTP application in databases?
That's a heavy question. So see, the thing is, this OLTP or OLAP systems, a small part of the big sort of impact that AI will have. I'm not sure if a data engineer's job will be around in 5 years, 10 years. I'm not sure. Or a database administrator will be around. These will be
We as
self-managed.
architects will be around. So
Well, we'll see. See, the thing is, as these systems get better, they'll obviously be able to design systems in natural language. So you tell them to do something, they'll do, and the only job will remain is going to be reviewing what they've done, what those systems have done. And I think that will be the challenge: how to tweak that, how to tweak those responses, from modeling to database optimization to ETL pipelines to analytical workloads. All of these things will still be required for sure. But how much effort goes in, like human effort goes into creating these pipelines, modeling these tables, or remodeling for analytical purposes? That's very hard to guess. But definitely it's going to be less human intervention. And I'm talking about, I don't have a timeline here, but obviously it's in a couple of years.
Good. Thanks, Kovid, for taking time and speaking to us on OLTP. I got to learn a few things, including what is ACID. So thank you very much for your time.
thanks, Kovid. It was a great learning experience talking to you.
Great being here. I learned more than you guys. So yeah, thanks for having me.
That was a fantastic discussion with Kovid on OLTP, and I hope the audience that are watching or listening to us on Spotify have learned a bit about OLTP and even migrations of OLTP to modern databases. Please do subscribe to our channel, like the video, put some comments, and let us know what do you think and what you want us to provide in future, what content we should do in future. Until next time, please be safe, take care, and goodbye.